Okay, well, so yes, again, very happy to be here to talk about quality control specifically for cookie and crackers applications. So during this presentation, we will see what are the main challenges related to this industry and what are the solutions that can help us overcome those challenges. I will finish by describing a few case studies, a few projects that we have done over the years in order to illustrate, the solutions that I'm going to present. So let's start. So first of all, I don't know if you know that, but biscuit is originally a French word. Here I would like to say, I would like to apologize in advance because in French, we just have one generic word, which is biscuit, to describe biscuits and crackers and cookies and all of those varieties. So this is really a generic term, and I don't think it exists in English, this generic term. So I might use the word biscuits when it's not exactly appropriate. So I'm going to ask you to forgive me for that in advance. But in any case, originally biscuit is a French word that is pronounced biscuit, and biscuit literally means cooked 2 times. The objective in the end is to obtain a hard product that is flat in appearance and that is crunchy or friable. And to obtain that, we need a final product with a low residual moisture content. And this is really one of the key parameters of this product, cookies and crackers and biscuits. I will come back to that in greater details. First of all, just a few generalities about those products, about cookies and crackers. They really constitute a universal pleasure as they are available worldwide. They are consumed for their nutritional value, for pleasure, of course, obviously, and they're accepted by all age groups. Also, they are very, very convenient. They have a long shelf life due to the fact that they don't have a lot of water remaining in the final products. And they are very practical, as you can eat it directly from the pack on your way to work or in the car, in the subway, or really whenever and however. Also, there are many different types available. You can find crackers or semi-sweet biscuits, where you can find cookies, including filled cookies or not. So everyone can really find the right product for him, what is the most appealing for him. But there is truly a choice for everyone. And also, especially because they can be found in many functional forms. They can be enriched in calcium, in iron, in vitamins. They can be formulated specifically for the children or for the elderly, also for people who have a specific diet, like people who exercise a lot, or people who are celiac, who need to eat gluten-free, or wholemeal flour, clean label. This is a very versatile product. And so for that, biscuits and cookies and crackers, they hold a very substantial share in the overall cereal products market. And this share is still expected to grow in the next few years. So this is truly a very interesting market for all of us here. And as I said, they exist in an infinite variety of end products, and so in shapes and size and color, in taste. Again, this is great for the consumers because everyone can find this product that is good for him. But that also means a technical challenge for the manufacturer, as it will require a very high viability of recipes, of processes, machines, of raw materials, including flour. And so this must be controlled specifically for each of those processes and also those end products. If we just here focus on the recipe in particular, in biscuits or cracker or cookie here in this case, we will find 4 main products: flour, sugar, fat, and water. And those ingredients, they can vary a lot in terms of proportion, in terms of composition. Additionally, you will find leavening agents, flavoring agents, eggs, milk, also chocolate chips, dry fruits, etc., etc. You can really put a lot of different products into those different products, into those different end products. And so the more complicated the formulation becomes and the more complicated it is to master everything and to understand everything. So we need to really focus on the quality of each ingredient, starting with the flour, which generally has the main is the main ingredient in those products. So to come back a little bit to the origin, to the context, when we talk about biscuits, we need soft wheats. So here, BAKERpedia, thank you, BAKERpedia, defines cookie flour as a soft, finely milled, low-gluten wheat flour that has been milled from softer wheat varieties, such as, for instance, soft red winter or soft white wheats. So soft wheats, that's the first thing. When we talk about soft wheats, that means that by definition, it is a wheat kernel that shows a low hardness. And this kernel will offer a low resistance to milling. And that is interesting because that means that from soft wheat, we will produce a fine flour with a low damage starch content. Additionally, soft wheat generally, they have a low protein content, between 8 and 10%, most probably. And all of that, the fact that there is a low damage starch content, low protein content, that explains the fact that in the end, the flour that we obtain will have a low absorption capacity. And this is good. This is something critical, actually, for cookies and crackers and biscuits. We need a low water absorption quality, because in the end, the objective, again, is to obtain a crunchy product, a hard product. And to obtain that, we need a low residual moisture content. So that means that the water that we put into the dough, well, we need to remove it at some point. We need to evaporate it during baking. And this water evaporation is a very costly step in terms of energy, and so also in terms of money. So basically, the more water you have to remove, and the more costly this step will get. So truly, water absorption is the first main technological challenge that we have to master. It will have a great impact on the production costs, but also it is the main influencing factors on the consistency and on the stickiness. And both must be controlled as well, because they will have a great impact on how the process runs. Also technological challenges that we can have during process are a dough that is not extensible enough. For example, we need a dough that is extensible enough so it will not break during shaping. And we need a dough that is not so elastic that it will shrink after shaping, after cutting. And those characteristics, extensibility, elasticity, that will impact the shape of the final product, its dimension, its thickness, its color, its final characteristic. And so those are very also important to control, to have under control. And finally, of course, the final product, a biscuit, should not have any defects, any cracks or blisters. So we will come back a little bit more in details on all of those challenges and see how we can overcome them. So the first challenge we have said was to keep viscosity under control. And for that, we have seen also that water absorption is the main cause. And water absorption is very, very important also for financial reasons, because we do not want to have too much water to remove during baking. Well, in terms of consistency, the technical challenge about the water will be that if you do not have enough water, the dough will be too dry and too hard and brittle. And so it will be difficult to manage. On the contrary, if you have too much water, if you put too much water into the dough, it will become soft and sticky. And this is truly something that we don't want. It will be also difficult to manage. in both cases, it will be difficult to manage. So really, water absorption will impact the entire process and also will have a key role in obtaining a compliant final products. So the question becomes, how do we measure, how do we control water absorption capacity? Well, here we have a very good tool to do that, which is called the MixerLab 2. The MixerLab 2 is a universal dough characterizer that will analyze the evolution of the consistency of the dough submitted to mixing, but also to temperature modification. So it is able to heat up and to cool down the dough. And that gives us information about many different parameters about the flour. Of course, its water absorption capacity, but also the behavior of the dough during mixing, its development time, its stability. We will also see when the temperature starts to rise, we will see how the protein reacts to this increase in temperature, their stability to this increase, and that will be an indication of the final volume. Then we will also see the gelatinization. And starch gelatinization is directly linked to the structure of the crumb. We will also have information on amylase activity, which impacts the color of the final product, and on when the MixerLab starts to cool down the dough, we will have also an information about starch retrogradation, which has a direct connection with the shelf life, the staling of the final product. So this is a very complete tool and really a great tool to understand how much water we can put into a flour to reach the correct consistency, the correct viscosity. But the question is that enough? To know how much water in total we can put into the dough, is that sufficient? Well, the answer is no. Is no, because we have three main components into the flour that can impact the water absorption capacity. Basically, you have the proteins, you have the damaged starch, and you have the fibers. And those three components, they will impact the dough differently as they absorb water. The glutenins will influence the dough elasticity and extensibility. The damaged starch will influence the dough stickiness. And the pentosanes, so the fibers, will directly impact the dough viscosity. So in the end, you can find yourself with two different flours with the same water absorption capacity, but with two different behaviors. One which can behave perfectly, and the other one we will get very sticky. So we need to control that. And here, in order to control that, well, we have the SLC CHOPIN. The SLC CHOPIN is a device that allows to understand where the water absorption is coming from by placing the flour in contact with different solvents. And each solvent has preference, let's say, for one of the main components of the flour, for the damaged starch, for the glutenins, and for the pentosanes. And so that will help us understand the individual contribution of each polymer on the final behavior of the dough. So this is a really complementary information to what the MixerLab can provide. The MixerLab tells us how much water in total. And the SLC allows us to understand why we have this water absorption capacity. What is it due to? And so we can really come back to the root cause of the problem in order to correct it. This is important. So then we have a second challenge. We have stickiness. Okay. Stickiness is a big issue. It is actually described by BAKERpedia. Again, thank you very much, BAKERpedia. I use your site a lot in order to find good definitions. And it is defined as the least desired property given the operational and cleaning issues that the bakery must deal with. So this is a serious issue that must be avoided at all costs. Question is, why is the dough becoming sticky? Well, because water is getting out of the dough, it's exiting the dough. The question is why? Why is water leaking out of the dough? Well, it is because at some point during mixing, we were able to put water, to put a certain amount of water to the dough, but then later on, it was released by the dough. And so question is, why does this happen? And generally it happens because the flour has too much damaged starch. So basically damaged starch loves water. When you place damaged starch in contact with water, it will absorb a lot of water. But damaged starch cannot retain water through the process. And so when submitted to constrained second mixing or shaping or whatever, it will have a tendency to release the water into the dough. And this water is then available for the proteins. But sometimes there is not enough proteins to really to take this dough to absorb this water. And so this is when the dough gets sticky. So truly, in the end, stickiness is a matter of balance between damaged starch content and protein content. So there is an ideal level of damaged starch according to the level of proteins. Basically, if you have more proteins, you are able to support a higher level of damaged starch. So when it comes to cookies and crackers and biscuits, we have said that we need soft wheats. Soft wheat means low protein content. So if we are dealing with low protein content wheats, that means that we can only support a small amount of damaged starch. So the question becomes, how do we control protein and damaged starch? Well, for protein content, there is a very easy solution, which is it can be very easily measured with NIR equipment, such as here the SpectraStar, which is a very precise equipment. And when it comes to the damaged starch, well, there is one very easy way to control damaged starch content, and that would be the SDmatic. So the SDmatic is a very simple, fast, and safe analysis to control damaged starch content. Basically, it is based on the measurement of iodine absorption. So I don't know about you, but when I was in high school, I did this experiment when you put a little bit of iodine on a potato or a bread or whatever product that contains starch. And you can see that iodine becomes brown or even dark, sometimes purple, even, black. And so what we are going to do with the SDmatic is prepare an iodine solution. And this iodine will create an electrical flow. This is what we will measure during the first phase. We will measure the electrical flow. Yeah, here it is. And once this electrical flow has reached a consistent value, we will add the flour. The iodine will fix on the damaged starch. And so basically, the more damaged starch you have into the flour, and the greater the loss in current will be. So the diminution of the electrical current will be more and more important as if there is more damaged starch. So this is the case here between those two curves. You have a blue one and a red one. One corresponds to a flour, the blue one with low damaged starch content, and with the red one, we have a high damaged starch content. And so this is why in the end, with only 1 gram of sample and in approximately 10 minutes, you are able to know how much damaged starch are in a flour. So third challenge will be extensibility and elasticity of the dough. So first, just a quick definition. The extensibility, for instance, is the capacity of the dough to be stretched without breaking. And this is important because a dough that is not very extensible will not be able to hold a shape. It will not spread during shaping. And if it's too extensible, it will not be able to hold a shape all the way around. And when it comes to elasticity, elasticity is the tendency of the dough to return to its initial position after deformation. So basically, you pull on the dough, you stretch the dough, you release it, and you see how it comes back. And this is important because if the dough is too elastic, it will have a tendency to retract, which impacts the size of the finished product. On the other way, on the other side, if it's not elastic enough, it won't hold the shape. So those two parameters, extensibility and elasticity, they will have a great impact on the final shape of the product. And they are both mainly related to the quality of protein network. And again, yes, it will directly impact the shape, the dimension, the thickness of the final product. And those parameters, the dimensional characteristics, they are particularly important to master, and we need them to be consistent. Why? Well, because manufacturers must respect the weight and the number of cookies packed in each package. If tomorrow I buy my favorite brand of cookies, which is supposed to have 15 cookies in the packs, and I only find 14, I will be very, very disappointed. So this is something that we don't want. And this would be directly related to the thickness of each cookie. If it's too big, well, maybe we will not be able to put 15 cookies, or maybe the global weight will not be respected. The diameter as well is very important. If the diameter is too big, there is a chance that the cookie will not enter the pack. That would be a big issue. And on the other side, no one wants a too small cookie that will break maybe in the package because the package is not made for this size. So those characteristics must be mastered. And again, they are mainly due to extensibility and elasticity. And which is where the solution is the alveograph. So here we can see the alveolar, which is the latest born of the alveograph family. And this is an equipment that measures the characteristic of the dough, such as extensibility and elasticity, by making a bubble. So basically, we will measure the pressure inside of the bubble of dough, until it ruptures. And that will give us a curve like that. On this curve, we will be able to find information such as the tenacity, which would be the capacity to resist deformation. We will find information about extensibility, which is the maximum volume of air the bubble can contain until it breaks. So this is what we can see here. This is the bubble rupture. We will have information on the elasticity as well, on the baking strength, and on other parameters that can all be very, very important to describe the rheological properties of a dough. And then we have two more challenges. We have color and we have the absence of defects. So first of all, color. Color, we all know this must be controlled because this is one of the first things that we see. This is one of the most important visual parameters. And the color is due to two chemical reactions, the Maillard reaction and the caramelization of the sugars. And those two reactions, they depend on the amount of free sugar that is available, both thanks to the formulation, because we add sugar into the dough, and also due to the fact that there is damaged starch. And if you have more damaged starch, you will produce more free sugar. And then you have cracks and blisters. Well, obviously, we need a final product that does not present any defect. So that is important. And well, we know that cracks and blisters are related to the amount of water to be removed during baking. Like if we have more water to remove, that can create some cracks and blisters, and also to the strength of the protein network. So both can impact the presence of cracks and blisters. And so how do we control that? Well, when it comes to color, we have seen that the reason behind is the damaged starch. To control damaged starch, we have seen that the SDmatic was the correct solution. And then we have cracks and blisters. So they are due to water absorption, which can be controlled by the mixer lab to know how much water the flour is able to absorb, and by the SLC CHOPIN, which tells us what are the components that absorb water. So why is the reason behind water absorption? And then we have protein quality that can impact cracks and blisters. And protein quality can be measured by the mixer lab for all that is mixing properties, so development time, stability, but also protein denaturation due to temperature. And then we have the alveograph to measure extensibility and elasticity, for instance. So in the end, if we try to summarize the key quality parameters that we have seen and the reasons behind, we have consistency of the dough, which is due to water absorption mainly. We have stickiness, which is also due to water absorption, but also to the balance between damaged starch and protein. We have the shape of the final product, so including the thickness, the diameter, and all of that, which is due to the protein quality and also to the water absorption, because the water absorption will impact the viscosity of the dough. Then we have color, final color of the products, which will be due to the free sugars in the formulation, both in the formulation and due to the damaged starch content. So more damaged starch, more free sugars, more pronounced color. And then finally, we will have the absence of defects, so the absence of cracks or blisters, which are due to water absorption and protein network strengths. And when we try to relate those key quality parameters to solutions, this is what we can get. So in the end, to master water absorption, well, we have seen that the mixer lab, this is something that I have not mentioned, but the alveograph as well, can help measure the total water absorption capacity. And the SLC tells us why we have this water absorption capacity. The NIR equipment can also provide a quick indirect measurements. If we have issues with elasticity, well, the alveograph will be the way to go. If we want to know more about the color, well, the SDmatic will be a great ingredient, and also for indirect measurement, the mixer lab can help. So basically, you have a whole range of product that is available to help you master the quality of the final biscuits and cookies and crackers. So here I would like to show you a few case studies, a few projects that we have done in order to illustrate what we can do with those equipment. So here I have a first example about SRC. So you have to know that SRC method, the solvent retention capacity method, was originally developed for soft wheat flours by Nabisco engineers. And it has been automatized by CHOPIN to offer greater precision. And in various studies, it has been proven possible to discriminate flours according to their quality and to even draw correlations with the final product. This is the case here of these studies. So you can find the reference here on the low part of the screen. But it has been possible to predict cookie expansion factor, the cookie diameter, the thickness, the hardness of the final product. And with quite a good precision, a very successful project. So basically, if you want to select a flour, like you know that you want a cookie factor that is lower than 4, then you know what SLC measurement you must get. And you can also predict what a specific flour, how a specific flour will behave. And so you can anticipate and correct if necessary. Here I have a second case study, which is about reduction of sugar content. So as we all know, I think at this point, we all eat too much sugar. And the recent World Health Organization guideline has recommended to adults and children to reduce their daily intake of free sugars to less than 10% of their total energy intake. So that's a big challenge. And the thing is that as cereal product manufacturers and cookies and crackers and biscuits, we can help because those products contain a lot of sugar. And so we could decrease the amount of sugar that is in these products. But the thing is that sugar is not used only for taste. It also has a tremendous impact on the dough characteristics. And so if we want to reduce the amount of sugar, then we need to anticipate this impact. And here, this is a study that has been done with the alveograph. And we can see that if we put more or less sugar into the flour, the behavior will completely change, and that will impact every parameter of this analysis. It will impact the tenacity of the dough, it will impact the extensibility, it will impact the elasticity. So truly, it will have a great impact on every step of the process and also on the final product characteristics. So basically, by analyzing your flour plus sugar with rheological equipment such as the albograph, then you can predict the impact of formulation modifications. Here, this is an example about sugar, but we have done the same with salt or with various raw materials, with enzymes as well. And so finally, a third study so the point here was to objectively control the water absorption at line. It was a project that we have done in collaboration with a biscuit manufacturer. And so this biscuit manufacturer relied on operators online to tell him if the dough was had the good consistency or not. Like they were touching the dough and say, this is good, or it lacks a little bit of water or whatever. And this is a solution that is widely used, having operators at line touching the dough. And this is good, but the fact is operators are not robots. They are humans with feelings, and sometimes they can get tired, and sometimes they are hungry or angry or whatever. And so all of that may impact how they feel things. So this is not a very objective measurement. Additionally, operators can leave. They can retire. They can change company. And between two operators, you will not have the same feeling at all. So this is a very complicated person to replace. So again, the point here was to develop a method that is objective to control the water absorption at line. And for this, for this challenge, we have used the mixer lab. What we have done is take portion of dough directly from the production line, so a real dough with water and flour and fats and sugar and enzymes and everything that you want. And we have placed it into the mixer lab. And we have measured its consistency according to various water amounts. So basically, with the same amount of flour and same flour quality, if you put more water into the dough, you will decrease the consistency. You will decrease its stiffness. And that can be measured with the mixer lab very clearly. And so that means that you can, one, determine the objective consistency, what is the ideal stiffness for having a good behavior online and for having a compliant final product. And then you can also model the impact of water on the dough stiffness. Basically, if we make the correlation between, so in this case, it was the torque measured after 2 minutes and the amount of water, we are able to say that 0.05 Newton meter of difference represents 0.15 liter of water. So we are able to link the mixer lab data with how much water we should add in order to reach a specific target, a target that we know and that has been objectively defined. So basically, this is an objective method to measure water absorption, and it has been easily developed. And it can be then used online very quickly after only 2 minutes of analysis, and very easily by not specifically trained operators. So we reached the end of the presentation. As a conclusion, I would like to say that I have presented a few case studies and a few solutions, but we really just started to scratch the surface. As over the years and over the partnership, we have done a lot of work, and we can consider many different applications, including the quality follow-up of the raw materials, including making correlations with the final products. We can analyze frozen dough, enzymes and ingredients. We can improve shelf life. We can do clean label. We can reduce sugar and salt. We can analyze gluten-free products, as it is the case here, where we analyze different rice samples in order to determine which one was the best for a gluten-free cookie. You can also analyze dough from the production line. So many different things to consider. And if you need additional information about one of those applications, or if you have questions, please do not hesitate to contact us. We will be more than happy to help. And really to finish, I just would like to say that CHOPIN Technologies is a brand of KPM Analytics. And KPM Analytics is a company that regroups various brands that can make NIR equipment, that can make functional and rheological equipment, as we have seen, wet chemistry analysis, and also machine vision inspection for food production, for biscuit production and packaging line, for instance. And that can also be a great tool in order to control and to better select your final products online. So a whole range of product is available to answer many different challenges. And I would love to give you more information if you want. But first, I would like to thank you very much for your attention and ask if you have any questions.